Hey, and welcome back. Today we're talking about Security Development Lifecycle Part 2. So as you already know, this video will be divided into 5 parts. And this part is about Microsoft SDL, verification through response, SDL optional tasks, and SDL for Agile. Microsoft Security Development Lifecycle. So for today, we are going to be looking at steps 11 through 17. We're going to be looking at the verification, release, and response phases and the steps within those phases. Perform dynamic analysis. Runtime verification of software programs is necessary to ensure that a program's functionality works as designed. This verification tests for specified tools that monitor application behavior for memory corruption, user privileges, and other critical security problems. Now, one of the tools that you can look at is through Veracode. It does dynamic analysis. This is different than static analysis. Again, this is something that you can feed your code to. It'll run the code, and then it'll show you any security issues that you have with that code. I strongly advise that you take a look at this. Perform fuzz testing. Fuzz testing is a specialized form of dynamic analysis used to induce program failure by deliberately introducing malformed or random data to an application. The fuzz testing strategy is derived from the intended use of application and the functional and design specifications for the application. The security advisor may require additional fuzz tests or increase in the scope and duration of the fuzz testing. Peach is an example of a fuzz testing tool. Take a look at it if you want to. Conduct attack surface review. It is common for an application to deviate significantly from the functional and design specifications created during the requirements and design phases of a software development project. Therefore, it is critical to re-review threat models and attack surface measurement of a given application when it is code complete. This review ensures that any design or implementation changes to the system have been accounted for and that any new attack vectors created as a result of the changes have been reviewed and mitigated. One of the tools that you can look at from OWASP is the Attack Surface Analysis cheat sheet. I strongly suggest that you take a look at it. Create an incident response plan. Every software release subject to the requirements of the SDL must include an incident response plan. Even programs with no known vulnerabilities at the time of release can be subject to the new threats that emerge over time. The incident response plan should include an identified sustained engineering team, or the team is too small to have SE resources, an emergency response plan that identifies the appropriate engineering, marketing, communications, and management staff to act as points of first contact in a security emergency. On-call contacts with decision-making authority that are available 24 hours a day, 7 days a week. Security servicing plans for code inheritance from other groups within the organization. Security servicing plans for licensed third-party code, including file names, versions, source code, third-party contact information, and contractual permission to make changes if appropriate. Conduct final security review. The final security review is a deliberate examination of all security activities performed on a software application prior to release. The FSR is performed by the security advisor with assistance from the regular development staff and the security and privacy team leads. The FSR is not a penetrate and patch exercise, nor is it a chance to perform security activities that were previously ignored or forgotten. The FSR usually includes an examination of threat models, exception requests, tool output, and performance against the previously determined quality gates or bug bars. The FSR results in one of 3 different outcomes. Past FSR, all security and privacy issues identified by the FSR process are fixed or mitigated. Past FSR with exceptions, all security and privacy issues identified by the FSR process are fixed or mitigated, and/or all exceptions are satisfactorily resolved. Those issues that cannot be addressed are logged and corrected in the next release. FSR with escalation. If a team does not meet all SDL requirements and the security advisor and the product team cannot reach an acceptable compromise, the security advisor cannot approve the project and the project cannot be released. Teams must either address whatever SDL requirements that they can prior to launch or escalate to executive management for a decision. Certify, release, and archive. Software released to manufacturing or released to web is a conditional on completion of the SDL process. The security advisor assigned to the release must certify that the project team has satisfied security requirements. Similarly, for all products that have at least one component with a privacy impact rating of P1, the project privacy advisor must certify that the project team has satisfied the privacy requirements before the software can be shipped. In addition, all pertinent information and data must be archived to allow for post-release servicing of the software. This includes all specifications, source code, binaries, private symbols, threat models, documentation, emergency response plans, license and servicing terms for any third-party software, and any other data necessary to perform post-release servicing tasks. Execute incident response plan. Being able to implement the incident response plan instituted in the release phase is essential to helping to protect customers from software security or privacy vulnerabilities that emerge. Now, you can take a look at this response plan from the Microsoft Security Tech Center. It might help you in coming up with your own response plan. SDL process illustration. So from here, you can take a look at the entire process. So this is our training. These are the requirements phase, the design phase, the implementation phase, verification phase, release phase, and response. Optional security activities. Optional security activities are generally performed when a software application is likely to be used in critical environments or scenarios. They are often specified by a security advisor as part of a negotiated set of additional requirements to ensure a greater level of security analysis for certain software components. For example, here we have a manual code review. A manual code review is an optional task in the SDL and usually performed by highly skilled individuals on the application security team and/or security advisor. While analyst tools can do much of the work of finding and flagging vulnerabilities, they are not perfect. As a result, manual code review is usually focused on the critical components of an application. Most often, it is used when sensitive data such as personally identifiable information is processed or stored. It is also used to examine other critical functionalities such as cryptographic implementations. Other optional security activities would be penetration testing, which we'll talk about in more detail in a future video. Penetration testing is a white box security analysis of a software system performed by skilled security professionals simulating the actions of a hacker. The objective of a penetration test is to uncover potential vulnerabilities resulting from coding errors, system configuration faults, or other operational deployment weaknesses. Penetration tests are often performed in conjunction with an automated and manual code reviews to provide a greater level of analysis than would ordinarily be possible. Vulnerability analysis of similar applications. Many reputable sources of information about software vulnerabilities can be found on the internet. In some cases, the analysis of vulnerabilities found in analogous software applications can shed light on potential design or implementation issues in software under development. Other process requirements. Root cause analysis. Upon discovery of a previously unknown vulnerability, an investigation should be performed to ascertain precisely where the security process failed. These vulnerabilities can be attributed to a variety of causes, including human error, tool failure, and policy failure. The goal of root cause analysis is to understand the precise nature of the failure. This information helps to ensure that errors of the same type are accounted for in future revisions of the SDL. Periodic process updates. Software threats are not static. As a result, the process used to secure software cannot be static. Organizations should take the knowledge learned from practices such as root cause analysis, policy changes, and improvements in technology and automation and apply them to the SDL on a predictable schedule. Generally speaking, a yearly update schedule should suffice. The exception to this rule is when new, previously unknown vulnerability types are identified. This phenomenon requires immediate out-of-cycle revisions of the SDL to ensure proper mitigations are in place going forward. Security Development Lifecycle for Agile. Microsoft has developed the SDL for Agile process to integrate critical security practices into the Agile methodology. The SDL for Agile development guidance reorganizes security practice into three categories: every sprint practices, bucket practices, and one-time practices. So let's take a look at the every sprint practices. So for every sprint practices, you need to use threat modeling in your design. For the implementation, you need to use approved tools, deprecate unsafe functions, and perform static analysis. For the release, you need to conduct a final security review and certify release and archive. So let's take a look at the bucket practices. So for the bucket practices, it means that important security practices that must be completed on a regular basis but can spread across multiple sprints during the project lifetime. So for bucket practices, you should, for the requirements phase, create quality gates and bug bars, and for verification, perform dynamic analysis, perform fuzz testing, and conduct attack surface review. So let's take a look at the one-time practices. So for the one-time practices, under the requirements phase, you need to establish security requirements, perform security and privacy risk assessments. For the design phase, establish design requirements, perform attack surface analysis and reduction, and for the release phase, create an incident response plan. Well, that's all that I have for now, and thanks for watching.